Hi guys, welcome back to my channel. Today I'm just discussing types of machines and its languages as well as examples. So this is Chomsky hierarchy. Using this hierarchy we can represent the different machines as well as the languages and also types of the grammar. So we know what is the use of grammar for define the language. So here the first circle represented as the first circle represented as type 0 grammar. We can say unrestricted grammar, and also the machine is called the Turing machines. So in this type of grammar almost supported all type of problems. So we can handle the unlimited memory as well as any kind of problems using this Turing machines. And the second one is context sensitive language. We can call the machine is called a linear bounded automations. So here they are handling the problem is it is a bounded memory. That's all. So this is a major difference between, but comparatively less power than the Turing machines. But anyway, we can solve the problems, but bounded cases. And also it is called type 1. And the next one is, it is a subset of Turing machines. And next one is context free languages. Here we can say the machine is called push down automata. Here we can handle this limited amount of memory, as well as here they introduce the stack answer, and we can call this grammar is called type 2. Almost all the programming languages constructed based on this context free grammar as well as context free language. And finally this is irregular languages. Definitely it will handle the limited memory, and the machine is called finite automata. So here they can use this machine is called finite automata. Okay, so next we'll see some. This is finite automata and applications. We can apply the pattern matching as well as string validations. Pattern matching, so generally we are using this regular expressions. So using this regular expressions we can match the content. Wherever we are applying the pattern matching, that place we can apply the finite automata, as well as we can use the string validations in generally in web bombs. So we are using the some strings. That time we can validate, for examples, if you are applying any applications through the online, so they are validating the string, they validating the address, they validating the phone numbers, validating the mail also. So in that case we can use this finite automata. This corresponding language is called regular languages, as well as this type of grammar is called type 3. And the context free grammar, so here we are applying this push down automata. uh, Generally we are using here some that is matching concept, that is for example balanced parenthesis. We have to match from one side again, come back to the next end. For example, balanced parenthesis means this is examples. Yeah, so we need to check the balance parenthesis. First you have to check the leftmost, again you have to check the rightmost. So if it is matching, we can announce this string is accepted, like this. So in this case we can apply the context free grammar. For example, palindrome, we can say A B A, again it will come to the reverse. A, B, A. So first part is, suppose we are reading the first part, again we have to match by the second part is matched by the first part. So in this situations we can apply this contextual grammar, and this is application can syntax parsing as well as validations of nested structures. In HTML tag, best example in HTML tag, how will you write, for example, paragraph, some content, again you have to use this paragraph. Okay, so in the situations, first you have to check, first you have to read, then again you have to recheck. So in the situations, for validation purpose, we go for this Yeah, in this situations, we go for the syntax parsing as well as validation of nested structures. Examples, we can say it is a type 2 grammar, and linear bounded automations. Uh, Here some restrictions of this memory consents, and as well as we can say resource constraints also. For example, the set of string consists of number of A's is equal to number of B's and number of C's. Okay, so some limited constraints we have to apply here. So in the situations, we go for the linear bounded automations, and we can say resource bound verifications. The corresponding grammar as well as language, context sensitive language as well as grammar, we can call the type 1. Okay, and the Turing machines, we can solve any kind of problems, but anyway, arithmetic operations like addition, subtraction, divisions, multiplications, and concatenations, and copying the content, as well as we can find the GCT, we can sorting also, whatever the problems, we can simulate the real world problems using this concept. So this is some example. Cryptography, we are designing the model for encryptions as well as decryptions. In AI, we are providing the model for decision makings, as either yes or no. Some sequences we have to write like this, and it is also called recursive and non-recursive, as well as recursive enumerable languages. And this generally, this grammar is called type 0. Yeah. So this is here types of the language as well as applications of the different machines. So next we will see what is the different type of problems, especially the problems comes under the Turing machines, decidable, undecidable problems, as well as machines, Turing machines, universal Turing machines, as well as what are the different languages, and recursive language, recursive enumerable language, and diagonalization language, and halting problems. So these are all the comes under the Turing machines. Thank you guys.